Welcome, everybody. We're going to get started. Demystifying SAML. We have a few housekeeping items. The Spring security team is hiring. So if you love Java, if you love Spring, and you want to work for Pivotal, please apply. Don't forget to rate the session. That is the mobile app you've downloaded. We're going to do QA. We're going to try to fit it in. If we don't fit it in, we're happy to answer any questions outside the room afterwards. We got a short time for us to move out of here when we're done. Most importantly, contributions to open source is not just code or PRs. You open up a bug request or bug report, that's a contribution. You write an article, that's a contribution. You ask a question and it gets answered, that's a contribution. So I love open source. Make sure you contribute in some way. So let me introduce my coworker.
Hello, everyone. Is it working? Okay. Hello, everyone. I'm Sree Tummidi, and I'm a huge Gamora fan. So, by the way, so alter ego, I'm a senior manager of product management at Pivotal, and I started off my career 14 years ago as a software engineer at CA Technologies, working on various enterprise security products, and then eventually moved to product management. At Pivotal, I was product managing UAA, which is an identity proxy. And then in my current role, I'm responsible for security of the overall platform, which is Pivotal Cloud Foundry.
Thank you, Sree. Sree is our identity superhero. If you turn a blind eye, then I aspire to be that too. At the end of this talk, we want all of you to be SAML superheroes. My name is Filip Hanik. I'm a software engineer. I currently work on the Spring Security SAML framework. We just started a rewrite to align it better with Spring Security, and we hope to make it part of the Spring Security offerings. Today, we're going to go on a journey. SAML is not an easy thing. I remember when I started reading, trying to figure out what is it, what do I need to know, how do I use it? Other than reverse engineering, where do I go? And I felt I'm not going anywhere. So today's journey, we're going to take you to nowhere. You're going to know everything about SAML that you do need to know. Sree and I did a presentation a couple of years ago on OpenID Connect, and we tried out what we call the demystify concept. Basically, how can we take something that's very complex and in less than an hour, make sure you're empowered when you leave here to take it further or to use it straight out of the box. We want to teach you what you need to know. And at the same time, how do we not overwhelm you with what you don't need to know? And we like to do this, but breaking it down all the way to the lowest level so that you can use it and walk away from here and understand what you're reading, what you're seeing, what it means. Most importantly, Sree and I are Infinity Wars super nerds, and we love that movie. So we're going to incorporate that into our story time. We want you to have fun here. We're going to be laughing at ourselves, so feel free to laugh with us. SAML had a little bit of an escalation path. Started out in 2002. In less than 1 year, we had a new specification, about 9 months later. In less than 2 years after that, we had a further specification. So from 2005, the last specification was worked on until 2012 when it was completely ratified with all the erratas. So what's going on? Why are we talking about SAML? Essentially, we're talking about something that's 13 years old. Why aren't we talking about OAuth OpenID and OpenID Connect? Well, we did that 2 years ago, and there's a great video. But SAML continues to perforate the enterprise. It is still the most popular single sign-on and single sign-off integration point there is. So while we see that OpenID Connect and OAuth is widely popular and much easier to work with for greenfield applications, SAML is still very important. And for an engineer to be in the field for 13 years, you might have never even heard of it. So it's a long time. So we like to bring back things that are important to us. Sree and I, at Pivotal, have also worked on Cloud Foundry UAA, which is an authorization server as well as a SAML server. So today we're going to take all of the SAML terminology, which can be pretty overwhelming, and we're going to break it down one by one until we figure out what it is. So what is SAML? Oh, wait a second. Who here has not watched Infinity Wars? All right, I'm going to spoil the movie rotten for you, so sorry about that. But if you go watch the movie after this, then they can't blame me for using their content, right? SAML is kind of like Thanos. So in Infinity Wars, Thanos is the villain. He's this mega beast that we don't really know what to do. And he's found a problem, and he's got an awful solution to it. But the problem is real, and he wants to solve it. And SAML is a little bit like Thanos. Right, I'm going to solve all these problems. Yeah, it's not going to look pretty, and you're not going to like it, but I'm going to solve it. So we're going to tell you a story. We're going to bring in a user to this, because after all, SAML, which stands for Security Assertion Markup Language, just the name makes me cringe. But since we're dealing with security, we're going to be dealing with a user. So we're going to bring in a user into our story. We're going to call him Peter. And Peter wants to use an application. He's never been inside of this application. Never used any of the services. He knows how to get there, but the application doesn't know who Peter is. So that's not a strange use case. Dr. Strange, right? I know, I've been practicing that one all morning. Well, in Infinity Wars, Dr. Strange gets trapped on the Q ship, and Peter wants to rescue him. But Dr. Strange has no idea who Peter is. So he needs someone to vouch for him.
Loyalty.
What? Stop.
I know what you're going to say.
You should not be here. You should not be here. You should not be here. You should not be here.
You should not be here. Right? Dr. Strange has no idea who Peter is. You can't come in here, help, I don't know who you are. So Peter needs someone to vouch for him. So he asks Tony, Tony, tell him who I am. So in our use case, Peter is the user. Tony's going to vouch for him. In the SAML world, we refer to that as an identity provider. And the application that he wants to access, we're going to call a service provider. To update the terminology a little bit, we typically refer to the user as a user agent, and that way it goes across OpenID Connect, OAuth, SAML, any other protocol you use. The application that needs to know who Peter is referred to as a relying party. So that's from the word rely. This application has to rely on somebody else to get there. That makes Tony the asserting party. We're going to assert. So to capturize, we have a user agent, asserting party, relying party. So we're going to bring up the speed a little bit. We need a lot of things to get SAML done. It is not an easy specification to pick up. As a matter of fact, it is 5 specifications. The first one is the metadata specification. This simply defines the rules or who an identity provider is or a service provider. The core protocol, so this is where most of us turn, right? I should probably read the core protocol first. It is nothing but like 80 or 90 pages of XML schemas. These schemas describe the messages that are being sent back and forth. So for that, obviously, we're going to need another specification, the binding specification. How do we send these messages back and forth? By now, we're so confused. We've read 3 documents, probably over 200 pages, and we have no idea what we're doing. So we need another specification, the profile. A use case is a profile. So Peter logging in from a browser to a web application, that's a profile. So this is probably the best document to start with if you want to immerse yourself. As if it wasn't enough, implementing this becomes very difficult. So we need a specification that tells us how to do that and how to conform to the other 4 specifications. Luckily, it's been 13 years, so we know what the reality is. This, by the way, this is the reality stone that Thanos is trying to get on his glove. And for us, SAML has really boiled down to a 90-10 use case, meaning 10% of what's in the SAML specification is used in 90% of the use cases. So let's take a look. I've created a demo. These slides, albeit they're scrubbed of non-approved content, are available in this repository as well. And we built up a couple of applications. Here is a Spring Security identity provider. We're going to log into this provider. So I am Peter Parker. My password is password because that's Peter. Hold on. Peter Parker, password. I'm now authenticated. I'm still on the identity provider. And I want to log in. And we reached nowhere. We're authenticated. We're on the service provider application. So our URL did change. We ended up on the service provider here, demo SP. And the application is kind enough to show us something called an assertion. Assertion. Great choice for a word. What is an assertion? A positive statement or declaration, often without support or reason. So when I first started working with SAML, I was like, well, there was not much support for it when I first encountered it, but I could never find the reason. So assertion does seem to be fitting. What did we just do? Peter wants to rescue Dr. Strange. He needs Tony to help him make the introduction. The profile we're going to use is our web profile. Remember the 90-10? Almost all SAML integrations use the web profile, meaning they're leveraging the browser to send messages. I'm authenticated against the identity provider. So for those who use big integration points like Okta, and it gives you a menu of applications, you say, I want to log in to my expense report application. That's a service provider. So you pick an application you want to log into, a service provider. All it does, it sends back an HTML form with an assertion. The browser submits that assertion. The application validates it, and you're authenticated. So what really happened? Let's dig in. I'm going to log out, and we're going to do this flow again. Let's go back to our identity provider. Browsers now have pretty nifty little tools for inspection, including SAML. We're going to turn off JavaScript. And let's log in. And once again, so I sent my request. When I clicked the link, I want to go to this application. The browser responded with an HTML form that auto-submits, but we disabled JavaScript, so it's asking me to do it manually. And here is our SAML response, a single hidden variable called SAML response. That's it. And now you can see why SAML is a little bit hard. It's not an easy little thing we're looking at here. We hit continue. And the browser did send the response back. The little Chrome extension was able to decode that data for us and present us with that XML. And inside of here, you're going to see that our assertion is in here. Buried deep, but there it is. We're not quite there with the framework itself. We have milestone releases out there. We want feedback. Go for it.
When are you planning on putting this into Spring Security?
When do we plan to put it in Spring Security? Well, so I was hoping that it would be an independent library by now, and we're reworking it a little bit to be in Spring Security, so I'm definitely hoping within, I would say, the next 6 months.
You have an old version of this now, right? There is a Spring Security SAML.
There is a Spring Security SAML as an independent library. We want it to be a submodule of the main Spring Security.
Was that written by the Spring guys?
That's this guy, Spring guy. At least for the last 4 months. Go for it, sir.
After you guys do roll it up in Spring Security proper, will it continue to be usable as a standalone module?
After we roll it up into Spring Security proper, will it continue to be usable as an independent module? Absolutely. The easiest thing to do, though, is the module today depends on Spring Security by having it be part of Spring Security proper, it's still a separate jar, it's still a separate artifact that you add as a dependency, but it's tied to a Spring Security version we know it works with. The question is, what are the limitations in the existing Spring Security SAML project? It's built on OpenSAML 2. And OpenSAML 2 stopped development a while back and has a few known CVEs that are not going to be addressed. It's not an easy way to upgrade from that because OpenSAML 3 was a complete rewrite with no backwards compatibility. So what we're trying to do is abstract all of that. Abstract all of that so that even if that changes or happens in the future, or if we wanted to bring in another library underneath it, we can totally do that. So Spring Security SAML will be built so that we can easily test it. Meaning, I don't have to deal with XML. I should be dealing with Java objects. I should easily be able to write tests that creates these objects so that I can write scenarios that test my integration points. It should also, you shouldn't have to deal with any OpenSAML library at all. So for those of us that used the previous, and the Cloud Foundry UA used Spring Security SAML 1, you notice that often when you extend it, you're extending org OpenSAML classes. We don't want that to be the case. We want you to implement our interfaces, extending our classes, so that we can ensure you maintain backwards compatible, and that's the main goal here. No love? We'll be here all night. We're going to close the doors. You're not going to get out of here until I'm done with the presentation. Go for it, sir.
So how does this compare with the JSON web tokens? SAML versus other OAuth?
The question is, how does this compare to OAuth or OpenID Connect and JSON Web Tokens? You know what? I'm going to let Sree come up here and talk about that because it is part of our presentation and we might as well cover it now.
Yeah, so we actually have a slide on that. From a differentiation perspective, I would say that OpenID Connect is definitely solving the same problem as SAML in terms of identity and single sign-on. But OpenID Connect is based on newer frameworks like OAuth and newer protocol specifications, which is JSON, JWT. So it's a much lighter weight option for achieving the same thing. But from a perspective of implementation, with SAML, you're using XML as a way of asserting the identity. Whereas with OpenID Connect, you are using a JWT, which is a JSON Web Token. From a security standpoint, it's pretty much a similar structure. Things are signed, encrypted. That support is there both on the SAML and the OpenID Connect side. But from a microservices security perspective, the recommendation is to go with something like OpenID Connect and OAuth because it gives you more flexibility. And it helps with different kinds of applications. So you could have a web application, a mobile application, an API, talking to another API, and using OpenID Connect is a better way to achieve microservices security as well as identity propagation.
And if you look at it, it's a super small world out there. The people that wrote the SAML specification, a lot of them transitioned over to OpenID Connect. I think OpenID Connect worked out a little bit better because they started with the 10% of functionality to achieve the 90% of use cases. So it started really small, and they're only adding features as extensions as opposed to making it part of the core protocol. But for example, OpenID Connect has a user info endpoint. SAML has an attribute query endpoint. It achieves the exact same thing. The content of an ID token is going to mimic what you have in an assertion.
You said OpenID Connect
The question is, do I think OpenID Connect will replace SAML in the future? I believe so. We did have the same question 10 years ago, will SAML replace LDAP? And I'm pretty sure we're still seeing a lot of LDAP out there. All right, I'm going to continue. So I would hope for at least for all new applications, you're using OpenID Connect and OAuth, because it is easier to work with. We're not going to go super deep into Spring Security SAML today because we are only on the milestone releases, but feel free to check out this repo and give us feedback. But what I want to show you is that hello world and simple things should not be difficult. So I want to write a test case is Peter Parker. And the assertion we just had. Right, this thing we saw on the web form, that giant thing, what is that? And Spring Security SAML itself uses a little utility class called Spring Security SAML. In this case, we're using OpenID, OpenSAML. And from that, we can decode our response. And then we can create a SAML object out of it. We're not doing any decryption or signature verifications right now, but if we have that, we have a super easy way to represent those keys. A SAML response, that was the XML object we saw. Now let's just do a simple assertion. Let's assert that that response, and in its assertions, we're going to look for the first assertion, has a subject, has a principal, that principal has a value. Guess what that is? It's the username. So we want that to be equal to Peter Parker. And that's our test case. But what we want to show is that this framework is going to complete. It's going to be pretty much, you're just going to plug in your user store. And then the endpoints are going to run themselves. Very rarely are you going to be intercepting this. But running this test and dealing with these XML objects should be pretty simple. So if we change this, just to show you I'm not playing a trick on you, we should probably get a failure by now. And that's right. There it is. Very simple, very straightforward. Okay. Identity provider initiated login. All we did was submit a form with a giant slob of XML. That slob of XML does have some valuable data. It's called a response. Where is that headed? Who is the intended recipient of that? Who sent that message? And remember, it's not the user that's actually sending the message. The user is just the middle point. And who do we describe? And just like a JWT token or JWT token, that assertion can be encrypted, or we can encrypt just the username itself. Okay, that brings us to Sree, who's going to talk about metadata.
Okay, thank you, Filip. Okay, thanks. Awesome. I hope you're all having fun. So we are going to switch gears and talk about the Soul Infinity Stone, which is referred to as metadata in our talk. The sole infinity stone is a special one which reveals all truths, and same is the case with metadata. So Filip showed a demo of the IDP-initiated login wherein you had an identity provider and a service provider, and they were sharing and exchanging sensitive information. The identity provider was sharing the user's information, and the service provider was trusting that information. So in an enterprise setup, the identity provider and the service provider are not necessarily sitting behind a firewall. You know, a service provider could be in a completely different domain. So trust is paramount in these situations. Most importantly, trust is a two-way street. It's not enough that the identity provider trusts the service provider. The service provider has to trust the identity provider as well. So over here, we have the Okta identity provider UI. And what we are doing is we are registering a service provider here. So this is one way in which information can be exchanged is you go to the identity provider's administrative screen and you register your service provider. So this is one way of doing it, but it is fairly manual. Another way is metadata can be made available as an XML in a URL. So what that means is, again, in an enterprise context, you know, when you're setting these things up, it's dynamic, things can change. Properties about the identity provider, properties about the service provider, they can change. And there should be a way to pick these up dynamically as opposed to configuring them statically. So this is another way in which you can share metadata between the two parties. So this is the big metadata that I'm going to explain. So this actually follows a schema which is governed by the SAML specification. What I'll do is I'll walk you through the common parts which apply to both the IDP and the SP for short, and then I will walk through things which are specific to an identity provider and things which are specific to a service provider. So both of the metadatas, they start off with the tag of entity descriptor, but the important piece here is entity ID. So both the IDP and the SP are associated with a unique identifier, which is called an entity ID. In this example, it is a URL, but it can be any unique identifier. However, you know, like as I've wrestled with setting up SAML trust relationships with different IDPs, one thing that you should keep track of is with the public providers. So we have Azure, which supports SAML, and in those scenarios, it's mostly a URL. The IDP entity ID is a URL, and it's expected that the service provider entity IDs are also URLs because you are operating over the internet and there should be a standard way to identify. The next piece of common information is the key descriptor. So we covered that assertions can be signed, they can be encrypted, but it applies again both to the service provider and the identity provider. You could have the service provider send signed authentication requests to the identity provider, and you can have the identity provider send signed responses or signed assertions in the process. Another piece of information is the logout URL. So logout URL is something that we'll explain further on, but for now, basically what this means is it's a way to log out the user from the various service providers that they have logged into through the IDP. So again, this can apply to both because logout can be initiated from both parties. There is another important piece of information here, which is binding, which specifies how this request response is initiated. In this case, it is a HTTP redirect binding. So it is initiated as a redirect and messages are flowing as query parameters. The next piece of information is the name ID format. So at the heart of it, what we are trying to do is assert on an identity or a subject, and the user identity follows a pattern. In most of the scenarios, I have seen email address being used, but there is an interesting one that I would like to call out, which is transient. What transient means is the identifier is applied only for that transaction. So there are situations, like where you consider the user ID to be a PII, like personally identifiable information, and you do not want to share that with third party. So just for the transaction, you will generate, the IDP will generate a identifier and share it with the SP, but not the actual ID within its system. Okay, now let's come to things which are specific to identity provider. The first thing is, it starts off with the IDP SSO descriptor as the tag, and it can also specify whether it only accepts signed authentication requests. So what that means is, if the service provider does not send a signed authentication request, the IDP will reject it, and the federated login will not occur, and it will error out. Finally, for identity provider, the most important piece is, where is the login happening? What is the location of the login? So that's what is under the single sign-on service URL. And the binding here is post. So you saw in the example how we are using a post binding for federated login. For service provider, it is the SP SSO descriptor. And there are two attributes. Service provider can also have an attribute which basically says, hey, I'm going to sign the authentication request and let the identity provider know. And another piece of information is whether service provider accepts only signed assertions. So if this is, again, set to true, that means if IDP is not sending a signed assertion, service provider will reject it. Finally, for a service provider, we have the assertion consumer URL. So Filip and I were joking about it, why this new term, why cannot we just use single sign-on URL? So that was a bit confusing. But assertion consumer service URL means where the service provider receives the assertion from the identity provider, and it has an associated binding as well.
Thank you, Sree. There are two things that were super important in what Sree said. The soul stone, that was part of Gomorrah, so that's why she's a Gomorrah, and she talked about the soul stone. So sorry for spoiling the movie in the back there. The other part was when we showed the Okta registration page. What Okta is asking you to do at that point is dig into this XML and extract it and place it into those fields. That is really what's taking place, because every provider, service or identity provider, will have their own description. We'll do a super simple demo here where we're going to reverse it a little bit. We'll go to the service provider section here, and we'll leave our SAML portion open, but we're on our little demo service provider here. And we select an identity provider we want to go to. In this case, we can actually go to a provider that runs on Cloud Foundry. And we're sending an authentication request to that provider. Now, that provider doesn't know who I am, so it does need to identify who I am. In Spring Security, often user, we're going to do user, password is the standard. And we're logged in at nowhere again. This time we actually have a few attributes. These attributes came back with the assertion in something called an attribute statement. So when we're talking about OpenID Connect and a JSON Web Token, well, these are token claims, attributes, same thing. Same, but different. And what took place here is that, again, we're using a web scenario. The browser, in this case, accesses the service provider directly, who now issues a 302. And in that 302, there's a SAML request parameter. So we've talked about bindings. Two of the bindings we've used now, the HTTP post and the redirect. The redirect has a size limit. Most web servers will not parse headers that are larger than 8K, meaning that whole request packet. And the assertion is bigger than that. So when we go to the identity provider, that assertion is too big, so it's using HTTP post to send that response back to the service provider. We validate that. And this is where Sree was talking about transient. Transient, that means I can use that user once. After that, my session expires. I don't know who you are. Or we can use persistent, meaning you have some identifier that we know is not going to change. All right, in the end, Peter and Tony, they do rescue Dr. Strange. So the story is over. In SAML world, we refer to that as we're signing off. But it's a feature in SAML, so let's go over how that works. In the web world, we're essentially establishing sessions everywhere. We're not going to be sending this assertion back and forth, because the more we do, the more we compromise it. If the user wants to log off or sign off, we can use the single logout feature. If we initiate it through the service provider has to contact the identity provider, who keeps track of all the assertions it's issued on behalf of your user, and log out of the other applications as well. And we're finally logged out. This here is an actual flow in SAML where you can use back channels. But again, it's not very often used and it becomes very complicated. In the web profile, what really happens is I'm sending my logout request to the application. Who sends the 302 redirect? Go here. The identity provider says, okay, but you need to go somewhere else first and log out. So it sends you to the other application you're logged in at, who logs you out. And you bounce back and forth until all your sessions are closed and you're back at the application, but you're not authenticated. And the exact same scenario happens if we go to Okta directly and say, I need you to log me out. Okta is going to bounce to your browser and push through. So that's a distributed sign-off. We close the sessions everywhere. And it can happen through back channel or through the most two common bindings, HTTP post or HTTP redirect. I'm going to let Sree talk a little bit about the features that SAML does have that we don't see used very often. We go out to enterprises and integrate very often, and very rarely do we touch on any of these features as a necessity to integrate our application into their identity.
Hello.
We need the other mic turned on, please.
Okay. So we'll try to tackle it as a group of features. So the first group is assertion queries, attribute queries, and artifact resolution. They all have to do with user claims. So assertion query is something, again, which is not widely used, but it is typically used to look up an existing assertion. So if an identity provider has generated an assertion, but for a given reason you want to go back, load the assertion again, it maintains a cache, and assertion query is a way to go and load back the older assertion. Attribute queries is an important profile because it lets you lazy load user claims. So what that means is, you saw how the SAML assertion was carrying user attributes, but you can only send so much information in one go. So if a user is part of thousands and thousands of groups that your application would like to receive, how do you make that possible? So that is made possible with the attribute query profile, wherein through a back channel you're able to query for more attributes about the user. Finally, artifact resolution is something which is used to get an assertion without a browser agent. So an artifact is generated for a transaction, and then you go take that artifact and exchange it for the actual assertion from the identity provider. When I was reading about this, I was thinking about the authorization code grant flow in OAuth, wherein you get a code, but that code gets exchanged for an actual token. The next set has to do with name identifiers. So again, this is not that prevalent. If there are multiple service providers and they all have to agree on name identifiers, so there is sort of like this configuration nightmare, and that's what these profiles solve. There is another aspect to this, which is if a name identifier, as in a user identifier, changes and you have to propagate that change across all service providers, how do you do that? And that spec goes into that. The final group is the relay state, ECP profile, and SOAP URI. So ECP profile is something that is used, it was a much later addition to SAML to deal with browserless scenarios wherein you have highly trusted applications which can collect the username and password as opposed to the identity provider, so you don't need a browser in the middle, and then send that information to identity provider for authentication. The relay state is something that applies to both identity provider and service provider, and it is something that is used to maintain a state for the concerned party. So if you are doing a SP-initiated flow, a service provider could throw a relay state on it for the sake of remembering where the user initiated the certain federated login or transaction, so that they can come back to the same point. So from a user experience perspective, I have seen relay state getting used, but it's heavily overloaded. Everyone has a very different understanding and implementation of this particular parameter. Finally, SOAP. So SAML has been used extensively for web services security, and that's where SOAP comes in. So SAML assertions can be encapsulated in SOAP envelopes, and they can be passed along in web services security related transactions, and that's where the SOAP binding comes in. I sort of discussed this during the time when we were having the snafu with the connection, but SAML versus OpenID Connect, just like a quick distinguishing of both of these protocols. So timeline-wise, SAML obviously is a much older protocol. OpenID Connect started in 2010, and there were still additions done all the way through last year. Format-wise, protocol and format-wise, SAML is HTTP and XML. OpenID Connect is REST with JSON. SAML obviously is much deep-rooted in the enterprise scenarios than OpenID Connect. OpenID Connect is built on top of OAuth framework, which has its beginnings in the social, in the social trend or the social age. So OpenID Connect is, being adopted more and more by the social identity providers, but it's finding roots in the enterprise. So if you see a lot of the enterprise identity provider products like Ping or Okta, they now have OpenID Connect support too. User claims in SAML, it's a SAML assertion that carries the user claims. In OpenID Connect, it's an ID token. Back channel communication to load more information, SAML does this with attribute query. In OpenID Connect, it is the user info endpoint. Browserless or native, SAML has the ECP profile. In case of OpenID Connect, if you want to do browserless, you can use the OAuth resource owner password grant, where the highly trusted application can collect the user's credentials. And then finally, a note on interop. So there are specifications out there to deal with exchanging SAML assertions for OAuth or OpenID tokens or vice versa. So this is obviously very important when you have a hybrid environment and you have certain applications that can understand only SAML. You have microservices, obviously, that can understand OAuth, OpenID Connect, but they need to interoperate, and that's where token exchange comes in. So a quick announcement. So UAA, Cloud Foundry UAA, and the Pivotal Single Sign-On Service, which support OpenID Connect, we recently certified. So they are now certified OpenID Connect identity providers, and they are now listed alongside other providers on the certification page. So what that means is we support all the profiles required to be supported, and we can interoperate with the standard libraries out there.
Thank you, Sree. The UAA, we often see a scenario where you authenticate into the UAA using a SAML assertion from your company's SAML provider. And then the UAA translate that information into ID tokens for the applications running on Cloud Foundry or outside of Cloud Foundry. And that information then becomes available through the user info endpoint as well. So it is a pretty nice way of being able to tie the two together. What do we talk about, and what do we want you to walk away with? Identity provider. It simply tells somebody else who you are. It's an asserting party. A service provider, that will be your application. If you need to integrate, you need to write a Spring Boot application that integrates with SAML. You will become, that application becomes a service provider or a relying party. Single sign-on and single sign-off are the two most common profiles or use cases. The two most common bindings are the HTTP redirect, HTTP post. If you fully understand those and how simple they are, but it looks so complicated when you're trying to read about it, then you are 90% there. Back channels are supported, but not very common. And we do have the similarities between OpenID Connect and SAML. So last time we did a Lord of the Rings theme, so now we kind of tie them together. Anyway, Thanos achieved his goal. And it wasn't pretty, but he got it there. And we didn't agree with it. And SAML does the same thing. And it's everywhere. And now that we can integrate it with it pretty simply, it takes us a long way, and we can work on it from there. All right. That is it for the presentation. We actually do have time for questions, right? All right, I can field some more questions. So for global sign-off, do we need to have an agent installed on the browser? You do not. So this will happen with redirects. So when your browser goes to the application and says, log me out, that application will send a redirect, a 302 response. The browser will follow that, and then it will bounce with redirects back and forth all the way until it's done. So if one of these applications fail to do a logout for you, it interrupts the whole flow. Correct. Go for it.
Typically, SAML is implemented in the infrastructure auth stack or security stack. And after the authentication or authorization, the application goes. In case of this, by providing a library, Spring library, how does it going to help? Or
So the question is, by providing a library, how's this going to help me? Basically, how it's going to do is that by you setting up the configuration, which is mainly the keys, right? You need to generate a set of a private key and a certificate to be able to exchange. With only a few lines of code, you're going to include a filter, and now your application has SAML endpoints. And you wire that up to an authentication manager so that you have your authentication object.
Just to add to that, I mean, since we are all dealing with open source, the way we plan on using, what we are doing in Spring Security on the UAA side is, UAA is an identity proxy. So we plan on using these profiles and the support for these profiles in Spring Security on the UAA side, because UAA needs to connect to existing identity providers. So we want to use the relying party or the service provider profile too in the UAA project.
Cool. Well, enjoy an extended break. Oh, there's one more. Everybody hang tight.
Say you're doing the relying party profile. Can you have a bookmark that goes directly to the relying party and flows will go through, or do you always have to log in first and then?
So the question is, if you're the application of the relying party, can you go there first? And the answer is yes. So if we're going to close down a little bit here, and I can show you. So I'm going to go to the service provider. This is the relying party, right? This is my application. And I've managed to connect my application to 3 different identity providers. 2 of them are Spring Security SAML applications. And I'm not logged in here, because remember when we logged in, we're at nowhere. So I go to another application, which happens to be an IDP and an SP built into one. So this application is going to assert my identity to where I started. But this application also needs someone else to assert your identity to it. So this jumps up, and let's take a look. We have our SAML introspector. We'll log in. And we see 2 posts. The first one goes to port 9093. It's a demo IDP SP all in one. That asserts the identity to that application. Then we're asserting our identity to the point where we started, our demo SP. So we chained the authentication, but we started at the application itself. And in this case, where I started was here. And if I wanted to log in, I can become Peter Parker. And I end up here as well. Does that answer your question? All right, well, I'm going to linger in the back. One more over there.
Is there an endpoint for the metadata generation?
The question is there an endpoint for the metadata generation? So first of all, thank you all for asking questions. You're making me feel more important than I am. The answer is yes. If we zoom in on the library here, I can go SAML, SP metadata, like that. What that actually did was that it did download a file. Oh, that was a bad thing to do. Bad mojo. Let's see, downloads. Show in Finder. Open it with a usable editor. And here's our metadata. So this was automatically generated based off of the configuration we have, which is really just the keys. these public keys.
Is it the same metadata for every IDP that you configured?
So the question is the same metadata for every IDP that we configure. What's going to change is the IDs for the metadata get auto-generated. So these unique IDs here. But the entity ID will be based on your URL, or you can configure it to be hard-coded. And it looks like there's a lot, but these URLs here, so single logout, those will be automatically generated based on where you're at. All right. In the SP. So the question was, how do I configure the IDP in the SP? Perfect. Good question. It's a two-way relationship. So let's open up our, and I'm going to make this a little bit bigger, but I have two IDPs configured here. And I'm going to give them, one is alias our Spring SAML, what's the text I want to show it, and where does this application download its metadata? Now, if I wanted to, you can put XML directly in here, right? So it was MD entity descriptor. That is a fully valid configuration as well. So we support XML either through a URL where we cache it, or you paste in the XML yourself. And we intend to support it just like Okta, where you just give me the 4 things: your single sign-on URL, your keys, your entity ID, and I'll take care of the rest. Does that make sense? Actually, we have 3 of them in here. 1, 2, 3. There are a couple more features that we're building in. Key rotation. A lot of libraries don't do that in the first go, so we're building that in. The other part is we're building in multi-tenancy as well. If you want your system to be multiple IDPs depending on whatever the input is. Either it's a subdomain or you have other ways of creating tenants. So that will be part of the library. It already is. Go for it. So the question is, do you recommend using the current library in production? That's a tough question. If it's already there, then it's already there. Would I pick it up today? You mean this one here, the 2.0? Yeah, I would be comfortable using that. The 1.0, if I'm starting a new project, is a little bit harder because we know there are defects in it. All right, we'll cut it there. Thank you very much.